In the last segment, we looked at exponents and what they mean. We looked at what we're talking about when we say the base of the exponential expression and what we mean when we talk about the exponent of the exponential expression. And then we also looked at some numerical bases to our exponential powers and how we would simplify to get the numerical values of those. Now sometimes we have exponential expressions where the base is a variable and the exponent then on the base might be involved in an operation that we can actually simplify the expression. And that's what we're going to do in this segment. I've written up the rules of exponents that we're going to talk about in this segment, and we're going to go through a couple different examples, first expanding it out to see why the rule is what the rule is, and then applying it to some further examples. So let's first look at this rule that says if you have a multiplication of two exponential expressions that have the same base, here the same base of x with our exponents on that it simplifies to keeping the base and adding the exponents. Well, let's do an example where the exponents are smaller numbers and see why this will be true. Let's say we have, for example, x to the second times x to the third. So it's a multiplication of exponential expressions that each have a base of x. Now, if I were to write this without exponents, my first factor here, x to the second, would be x times x. But it's involved in a multiplication in this example, so it's times. And then my x to the third is x times x times x. So I've just rewritten that problem without using its exponents. Well, because it was multiplication, and because they were all the same base, I really just have a repeated multiplication of x, but there are 1, 2, 3, 4, 5 factors of x. So I can write that back into the notation of the base of x with an exponent of 5. So now when we look at what we get for the simplification and back up to the problem that started, we see that we could have taken a shortcut from our original problem to the answer by noticing that here I will keep the base and add the exponents. So as another example, what if we had x to the 21st times x to the 15th? Certainly I could write out 21 factors of x times 15 more factors of x, but that would be a long drawn-out process. Since I noticed with the smaller example that I can get to the answer by when I have exponential expressions that are involved in a multiplication and they have the same base, my answer is keep the base, x, and add the exponents. 21 plus 15 is 36. And I get there in a much quicker way without as much writing. So that's our first rule. The next rule is, what if we have an expression like x to the second raised to the third power? Notice how this is different than the example that we just did. In the example that we did before, I had two separate exponential expressions that were to powers, but they had the same base and they were involved in a multiplication. Here, I have an exponential expression that's a base of another exponent acting on it. So that's what you want to really compare and contrast so that you can keep these rules straight. Well, let's expand this one and write it without exponents. X to the second raised to the third power means that I'll have x to the second times x to the second times x to the second. But each of these x to the second powers are x times x. So this is x times x times x times x times x times x. But when I get to this stage, it's all multiplication and it's all the base of x. And I see that I have my base of x and I have 1, 2, 3, 4, 5, 6 factors of x, so that's x to the 6th. So when the rule states that you're taking an exponential expression to yet another power, we keep the base and we multiply the exponents. So as another example, what if I have x to the 9th all to the fourth power. Well, this is an exponential expression to yet another power, and that's where we keep the base and multiply the exponents. So this will be a base of x, and 9 times 4 is 36. Now be careful that you keep that straight from what we did before with just numerical bases to powers. When I just had a number base to a power, I would take that number base times itself as many as what the power indicates. But this is an exponential expression to another power, and I'm keeping the base and then multiplying the exponents to get there.